Today's lesson is writing numbers in scientific notation. Our learning targets: I can determine whether or not a number is written correctly in scientific notation. Our second learning target: I can rewrite numbers so they are written correctly in scientific notation. Scientific notation. Numbers in scientific notation have two parts. We have the coefficient. The coefficient is greater than or equal to 1 but less than 10. And then we have multiply by a power of 10 with a whole number exponent. So let's practice deciding whether numbers are actually in scientific notation. Decide whether or not each number is correctly written in scientific notation. Let's look at the first one. 4.56 times 10 to the negative 8th. So we look at our coefficient and we look at our exponent. Coefficient, remember our rule, if our number in front of our decimal has to be equal or greater than 1, but less than 10. In this case, it's 4. Yes, that fits. And we look at our exponent. It's it's a whole number, so that one will work. Let's go down to 10.34 times 10 to the 9th. Think of our coefficient rule. Number in front has to be 1 or greater or less than 10. This is 10. This will not work. The coefficient must be less than 10. Looking at our next one, 0.73 times 10 to the 5th. Think of our coefficient rule. It has to be 1 or greater, but also less than 10. This one would not be. The coefficient must be greater than or equal to 1. Looking at 27.5, looking at our coefficient of 27, we should know the coefficient must be less than 10, so this one is not. 9.99 times 10 to the negative 5th, we look at our coefficient of 9. Yes, that one works. And our last example, 7.002 times 10 to the 7th, this one will work as well because our coefficient is between 1 and less than 10. All right. So when numbers are not written correctly in scientific notation, we just can't leave them. We actually have to fix them. So looking at this example, 12.34 times 10 to the 5th. This number is not written correctly in scientific notation because the coefficient is too big. Remember, the coefficient has to be greater than or equal to 1, but less than 10. This is 12. It has to be less than 10 in this case. We can fix this number by moving the decimal and changing our exponent using our acronym that we've been going over of LARS. So here's a little review of what LARS is. L stands for left. So if we move our decimal left, we need to add. So A stands for add. If we move our decimal to the right, we need to subtract. So L is left, A is add, R is right, and S is subtract. So the left and add go together, or right and subtract go together. Add 1 to the exponent for every place value you move to the left. You subtract 1 for every place value the decimals move to the right. So let's fix this number, 12.34 times 10 to the 5th, using LARS. So what we need to do, first thing we have to do is put the decimal in the correct spot. We need to move it over, 1 to the left. So thinking of our acronym of LARS, we moved it left, so L and A go together. So we need to add. So what we need to do, being that we moved our decimal, we need to change the exponent so the value keeps its true value. So the number keeps its true value. So if we moved it 1 place value to the left, we need to add 1 because we only moved it 1. So we're going to add 5 plus 1. So in the LARS, the decimal was moved 1 place left, so we need to add 1 to the exponent. So our answer would become 1.234 times 10 to the 6th. So there's 2 steps in every one of these when we need to correct a number in scientific notation. We need to move our decimal to make our coefficient correct, but then we have to look at how many place values did we move. and which direction, left or right, that's going to change our exponent, depending on which way we move. Let's look at this one. Let's try to fix it. We have 773.98 times 10 to the negative 8. So first thing we need to do is put the decimal in the correct spot. We should know that we need to move our decimal between the two sevens, because this coefficient has to be 1 or greater, but less than 10. Since we are moving it 2 places, we're going to be using 2 in here to help figure out our new exponent. So now that we moved the decimal, we need to change the exponent so the number keeps the true value. So if we did that, the decimal, we moved 2 places left. So we need to add 2. So left, L, left, we need to add. Since we moved 2, we need to add 2. So be careful when we're dealing with negatives, though. It's going to be negative 8 plus 2. We have opposites. We have opposite signs. We need to subtract. So 8 minus 2 is 6. There's going to be positive, or there's more negatives in it, so our answer is going to be negative 6 for our exponent. So our total answer, the correct form of scientific notation, is 7.7398 times 10 to the negative 6. Don't be afraid to use your calculator on this. Negative 8 plus 2. Let's look at this one. This one's not in correct scientific notation. We have to move our decimal. We need to move our decimal. This is too small, right? We need to have it 1 or bigger, but less than 10. So that means we got to move our decimal 1 to the right. Looking at LARS, we need to subtract. Since we moved it 1, we're going to subtract 1. So 9 minus 1 will be 8. So 9.87 times 10 to the 8th will be our final answer. All right, we have 0.00112 times 10 to the negative 6. First step, we need to move our decimal to the correct spot. Our decimal is going to move all the way to right here between the ones. So we're moving it to the right. 1, 2, 3 places. So right now our coefficient is 1.12 times 10 to something. So we know we moved it 1, 2, 3 place values. We're going to be doing something to it. So we're moving to the right. Right means we're subtracting. So we're going to subtract 3 because we moved it 1, 2, 3 places. So negative 6 minus 3 would be negative 9. So our final answer would be 1.12 times 10 to the negative 9. Don't be afraid to use your calculator. Negative 6 minus 3 would be negative 9. Now let's try some on your own. All right, so pause the video. Try these 6 problems. Put the following numbers in the correct scientific notation. All right, let's go over our first one. So we have 45.6. We need to fix our coefficient. We need to move our decimal 1 place to the left. Since we move left, we're thinking LARS, L.A. So left and add. So we're going to add 1 to our answer. So we move it over, so it's going to be 4.56. Negative 8 plus 1, because we moved it 1 place value to the left. So negative 8 plus 1 is negative 7. Next one, 10.34 times 10 to the 9th. We need to move our decimal. 10's too big, so we're going to move it 1 to the left, just like we did from above with LARS, L.A. So we need to add 1. So our coefficient is going to be 1.034 times 10. We have to add 1 to this to the 10th power because we moved it 1 to the left. Next one, 0.73 times 10 to the 5th. This is not in proper form. It's too small. We need to have a number at least in front of our decimal, a 1, or bigger, but less than 10. So if we have to move our decimal to the right 1, so think of LARS, L-A-R-S, so we're looking at the R and S since we're moving it to the right. R is the right. Since I moved it 1 place, we're going to, S stands for subtract. We're going to subtract 1. So our answer is going to be 7.3 times 10 to the 4th. I subtracted 1 from the 5. Moving over to the other column, 270.5 times 10 to the 11th. So this time, 270 is way too big. We need to move it 2 place values. We're going to put our decimal between the 2 and the 7. So our coefficient would become 2.705. Being that we moved to the left, think of LARS, L and A means add. Since we moved 2 place values, we're going to add 2. So our answer is going to be 2.705 times 10 to the 13th. 11 plus 2 is 13. 909.09 times 10 to the negative 5th. 909 is way too big, so we need to move our decimal 2 places. So our decimal is going to fall between the 9 and the 0. So our coefficient will become 9.0909. Being that we moved left 2, left in LARS, L and the A, so we need to add 2. In your calculator, you can go -5 plus 2, you get -3. So our final answer will be 9.0909 times 10 to the negative 3rd. And our last example, 0.0072. This coefficient is way too small. We need to move our decimal 1, 2, 3 places to the right. In LARS, we're looking at L.A.R.S, so the R is right, and the S means subtract. Since we moved it 3 places, our coefficient is going to be 7.2, and we're going to subtract 3, being that because we moved 3 places to the right. 7 minus 3 is 4. So 7.2 times 10 to the 4th will be our answer. How did we do? If you are getting hung up on these, please contact your teacher. So now let's apply this to multiplying and dividing numbers in scientific notation. So if we had this problem, 6.25 times 10 to the 3rd times 3.92 times 10 to the 6th. Let's think of this. So first thing we need to do is multiply our coefficients. So we have 6.25 times 3.92. When we multiply that together, we get 24.5. The next thing we do is we need to multiply the powers of 10. When we multiply our powers of 10, we keep the base, but we add our exponents. So we're looking at the 3 and the 6. We keep our base of 10. 3 plus 6 is 9. And the last step is putting this all together. We're going to combine the 24.5 times 10 to the 9th. Our last step is check to see if this is in scientific notation, and it is not. But we're looking using the LARS acronym. We need 24 is too big, so we need to move it 1 to the left. Left means add. Since I moved it 1 to the left, so our answer, our correct coefficient will be 2.45. And since we moved it 1 to the left, we're going to add 1. So 9 becomes 10. So our answer is 2.45 times 10 to the 10th. The decimal moved 1 left, so I added 1 to the exponent. Let's take a look at a division problem. Our first step. So I'll read the problem. 2.415 times 10 to the 9th divided by 9.66 times 10 to the 4th. Our very first step, we need to divide our two coefficients. So we need to divide the 2.415 divided by 9.66. And when we get that, we get 0.25. Our next step is we need to divide the powers of 10. When we divide powers of 10, we are actually going to keep the base, but subtract our exponents. So our exponents are 9 and 4. 9 and 4. We're going to subtract them. So 9 minus 4 is 5. So our exponent, a power of 10 with our exponent would be 10 to the 5th. Then we put all our pieces together, so we're going to combine these. So 0.25 times 10 to the 5th. We use LARS to see, we put this in scientific notation. We should know that 0.25 is too small. It's not in the correct form. So we need to move our decimal 1 to the right. When I move right, I'm going to subtract. Since I moved to only one place, I'm going to subtract 1 from our exponent. So our answer would be 2.5 times 10 to the 4th. I moved 1 right, so I subtracted 1 from the exponent. All right, so please email your teacher with any questions and head on over to Schoology to complete a short practice.